Working with managed code. Alright, we have a really cool video here on integrating two of the most powerful technologies out there today. And of course I'm talking about SQL Server 2005 and also the .NET framework. So really what this version of SQL allows us to do is build certain SQL Server objects such as stored procedures and user-defined functions in our favorite programming language such as Visual Basic .NET or C#. So really what this allows us to do is we're not just restricted to the Transact SQL programming languages when we want to build our stored procedures or our user-defined functions. We can use our favorite programming language to do so instead. And this is going to allow our developers to have a lot more freedom and flexibility when building these objects. Not only that, there's many other benefits in doing so too, which we'll take a look at here. But before we get into everything, let's just take a quick peek at our outline. We're going to start off here with an introduction to managed code. I'm going to get you familiar with the CLR, the Common Language Runtime. And really, it's just the heart of the .NET framework. So we'll get an introduction to that. I'll also kind of give you a visual of how the process works. And then we'll get familiar with all the different types of objects we can build in the .NET framework, such as, again, stored procedures, user-defined functions, and such. And then I'll also give you some, again, those advantages and benefits to building a CLR stored procedure as opposed to building a SQL Server stored procedure. And, of course, those are circumstantial scenarios for building each of those types of objects, which we'll take a look at. We'll also take a look at here at creating CLR objects. We'll open up Visual Studio.NET. We will build a couple of stored procedures, a couple of user-defined functions using Visual Basic.NET. So we'll get familiar with building some of these types of objects over there, and very simple ones. We'll get familiar also with Visual Studio if you're not already. And then here at the end, we'll get familiar with implementing all of these objects. We'll learn how to turn CLR integration on in SQL Server. We'll import the results of our programming efforts up here, which are called assemblies, which are really DLL files in this case. We'll import those into SQL Server. We'll learn how to use them as stored procedures, and we'll take a peek at a couple of other things along the way. Alright, so I'm a big fan of this integration stuff, and really it's because the people that benefit from this are us, the users, the developers, the administrators of these platforms, and it's simply because the more technologies integrate, the more options we have available to us when scenarios and situations arise. So cool stuff here. Let's jump right into an introduction and get familiar with how the SQL Server CLR integration stuff works. First off, just a little bit about the Common Language Runtime. Again, it is the heart of the .NET framework. It is the engine of the .NET framework. How this basically works here is we build, Windows applications or web applications or just plain old code libraries, which are DLLs here. We build these in our favorite programming language, such as Visual Basic.NET or C#.NET or J#.NET, which is Java. No matter what language we build them in, it all gets compiled to the same code. It all gets compiled to what's called MSIL, the Microsoft Intermediate Language. And then this code gets run through the Common Language Runtime whenever it's executed. The Common Language Runtime then compiles this code into native machine language code, and boom, it's off and running. And the nice thing about this is that the Common Language Runtime doesn't discriminate, right, against programming languages. No matter what programming language you build to, it all gets compiled to the same code. Therefore, there's no performance advantage to any programming language, really. It's all just preference at this point of what programming language you like to run. So that's really why it's called the Common Language Runtime, because it's common across all programming language platforms. So at the end of the day, it's just the .NET framework, no matter what programming language you're working in. And a really nice thing is I can build an object or a library, a code library in one programming language, give it to a program in another programming language, and they can use it. So in the past, it wasn't always like that. Each programming language had its own runtime engine associated with it. And although we could do some form of integration, it wasn't near the level of the Common Language Runtime, a very integrated system across all of these programming languages. Now, code running through the CLR is considered managed code, and it's called managed code because the CLR is managing all kinds of processes underneath the hood. It's managing the process of loading our DLLs and code libraries into memory, converting this MSIL code into native machine language code. It's managing our objects in memory, it's disposing of them in memory using what's called the garbage collector, and there's a whole host of things that the CLR handles that we don't have to think about as programmers. We can focus on just simply the functionality, which is why all of these, the .NET framework is considered the rapid application development environment, because we can build these things in no time flat, which is another reason that we can integrate, is a good thing to integrate with SQL Server, because now, we can build things that we could do in Transact SQL that we really would take us a lot of time to do in Transact SQL that we can do in seconds in a standard, full-fledged programming language, we can now do. So really cool stuff here. All right, let me show you a little bit how this process works from when we build these actual DLLs or these assemblies, import them in the SQL Server, and then have our database developers create stored procedures off of them. How this works, we open up our visualstudio.net over here. So this will be visualstudio.net, and basically what we would do is whip out our favorite programming language, VB.net, C#.net, J#.net, C++, whatever you can think of, anything that's compliant with the .NET environment. We would open up, we would build our DLLs. We would build a DLL, or what's known as a class library. We would have classes in there. We would have methods and functions within those classes to do the actual work, right? Once we're done building it and coding all that out, we would compile it into a DLL, otherwise known as an assembly. We would then take our assembly and import it into SQL Server. Basically, at this point, we would of course give that DLL to an administrator, and an administrator would then import that assembly into SQL Server, grant it what's called a permission set, which is just basically telling SQL Server what type of resources this DLL or assembly can access. Once it's imported into SQL Server, that's it. Now it can be used. And we'll have our developers over in our database developers in SQL Server Management Studio here, SSMS, create just a stored procedure wrapper, really not a lot of work at all to create a wrapper around the stored procedure code that we built over here. Because remember, all the code is really going to sit over here. All the logic within our stored procedures, our user-defined functions, is going to sit inside of this DLL, because this is where all the work is. All the work is over here in Visual Studio. We just create wrapper stored procedures and wrapper functions that wrap around this functionality, and then we call stored procedures just like we would call a stored procedure out of SQL Server, user-defined function. They work just like standard SQL Server objects, although they're not. They're CLR objects. So what would happen is then we would build these wrapper objects. We would use these wrapper objects over here. SQL Server, once it gets a request to execute a stored procedure, for instance, that isn't a standard SQL Server stored procedure, it would say, oh, this is a CLR stored procedure. It would then pass that off to the CLR. The CLR would do everything else. It would load this DLL into memory. It would then, fire off all these methods and do whatever it had to do, and then return the results to SQL Server, which would then return the results to the user. And this actually looks like it's a lot of extra steps. It really isn't, because again, SQL Server and CLR are tied directly to one another, and since the CLR is so good at doing its job, we would actually get a performance boost on certain stored procedures and user-defined functions, again, depending on what we're doing. But that's the process. We build these code libraries, we build our assemblies over in Visual Studio, we import them into SQL Server, and then we create wrapper stored procedures and functions and such around the methods within these objects. And then we can use them just like SQL Server objects. Okay, so what type of objects can we build in the CLR? Well, we can build user-defined functions. Of course, your standard scalar-valued functions, table-valued functions, and a new one here that we can't build inside of SQL Server is streaming table-valued functions. Basically, what a streaming table-valued function is your standard table-valued function, when you use it in SQL Server, it has to do what's called, it has to materialize. It has to materialize in memory. In other words, the whole thing has to be run, the entire record set has to basically come together before it can be returned to the user. A little bit different with the CLR and streaming table-valued functions, and this is another reason why performance is so good. Once you do an STVF here, basically what that does is it returns it one row at a time. So it pages through and returns it as it's executing. So you see the results while it's still fetching results, which is a really, really cool thing. And I'm actually got a good demo here on exactly how a streaming table-valued functions works. We'll build one over there in Visual Studio, import it, and use it. We can also build user-defined aggregates. And this is really cool. This is something there is no SQL Server aggregate object that we can build. Basically, we can build our own sum functions or count functions. Those aggregate functions built into SQL Server, yeah, you can build your own and then import them and use them as user-defined aggregates, CLR user-defined aggregates. So that's pretty cool stuff here. You can also build your own user-defined types over in the CLR engine. We can build our own triggers, and we can build our own stored procedures. So these are the SQL Server objects we can build in the CLR. Why would we want to do all this? Well, one of the big ones here is going to be performance. Take the Transact SQL language, for instance. This Transact SQL language was built for data access. That's what it was designed to do. That's what it's best at doing. So that's what it should always be doing. And I can't tell you how many times in the past, because we didn't have any other options, that I would try to do programming language things within Transact SQL, and you didn't have a choice in the past. For instance, complex string manipulation. Boy, is it a pain to substring out hundreds of things when you're trying to do them in Transact SQL. Your code gets bloated, hard to read, and it's not fast at all. Transact SQL is not good at doing programming language things. As I said, it was built for data access. So performance a big thing. Also, we're just going to save a lot of time in general now that we can do programming language functions within SQL Server now. And again, CLR for everything else. CLR is great at complex calculations. It's great at control of flow statements, decision making, string manipulation. The list goes on and on. Pretty much everything that isn't data access, use the CLR for. You'll gain significant performance advantages, and you'll be able to do it in a quarter of the time that you could do it in Transact SQL. So what if you're doing a lot of both? What if you're doing a lot of data access and a lot of complex calculations? Well, I would bet that the CLR will outperform even Transact SQL in that case, because the CLR and these assemblies are sitting on the SQL Server, and you are going to have Transact SQL statements in that scenario inside of your code modules here. So, I would say it's debatable. Really, what you would want to do in that scenario is test it out. Build a Transact SQL store procedure, build a CLR store procedure, do some benchmark testing, and find out. My bet, again, is that the CLR will probably outperform Transact SQL in that scenario, just because it'll do the calculations a lot faster than Transact SQL would. Also, as I mentioned, we get all the programming language benefits. We can use collections, arrays, for each loops, some of those advanced programming concepts that would be nearly impossible, if not really extreme, to do in Transact SQL. Also here, object-oriented programming capabilities. We can use inheritance, polymorphism, relay classes. Again, these are all kind of advanced object-oriented programming language constructs, but we have them at our disposal. Another really big thing here is when you're working with a lot of code, it's a lot easier to manage using object-oriented, mentioning some of the things I just mentioned, and it's a lot easier to maintain as well, because I have one spot here where all of my code is maintained, and if I have other developers that can reuse this code, I can just hand them out this DLL and say, here you go, here's my DLL, here's what it's attached to it, use the functionality of it. So now I can have SQL Server using these DLLs and SQL Server users, and also other programming language users using my DLLs. Now, if I need to make a code update, I just update it in one spot, redeploy it, boom, everything sees my changes. Of course, we have to actually tell SQL Server to update the change, which I'll show you how to do when we get into the environment. But the point is, a lot easier to maintain and manage than all of our Transact SQL code scattered around everywhere. Alright, the first thing we're going to do now is jump right into Visual Studio, and we're going to create a couple of user-defined functions. We're going to import them and use them, and then we'll do the same thing for stored procedures. So let's get a few environments open up here. Let's first head on down to the Start menu, up to Programs. First thing I'm going to open up is Visual Studio 2005 here. So let's go down to Microsoft Visual Studio 2005 and Microsoft Visual 2005 once again. I built a class library here that's going to compile into a DLL file, and this is called the SQL library file here. So we'll open this up, and you can see here, look at this, I have a class for each one, a class for UDFs, a class for stored procedures. If we were built user-defined types, we could make a class for user-defined types, but it's one project to manage all of these objects. We're first going to take a look at UDFs here, so I'll just open this up and I'll run through how this code works. Next thing we're going to do is let's fire open SQL Server here. Let's head on down to Start, up to Programs, over to SQL Server 2005, and right down to SQL Server Management Studio here. We're going to connect this up to our production instance, and there's an Object Explorer connection. The next thing I'm going to do is open up the script that we're going to be working with here. So we'll open up our managed code script and also hook this up right into production and our AdventureWorks database. And again, we're first going to build our actual user-defined functions and store procedures over in Visual Studio and create these DLLs. We're going to create these assemblies, and then we're going to import them over here in SQL Server and learn how to use them. So let's head on over to the SQL library here. And the first thing we're going to build is a scalar valued functions. And just to show you how I have this set up here, here's how it looks. I actually have two classes within this .vb file, and really, usually when you create a class by itself, it comes like this. It's just one class in a file here, as you can see. But I actually broke this file out into two classes because we're going to have an SVF, a scalar valued functions class, and a table valued functions class, all wrapped into a UDF, user-defined function, just a file here. This isn't really a class here. Basically, the first thing we need to do is we need to have certain libraries imported so we can use and kind of tell that this DLL that it's SQL Server aware, right? So the first thing we need to do is make sure that you have imports Microsoft.SQLServer.server here, and this will import and give us all of the SQL Server functionality we need to make stored procedures, user-defined functions, triggers, and all of those database objects. Also, if you're going to do any data access here, we need to import the system.data.sql and system.data.sql client. What these import statements do is these import other DLLs you can think of, other libraries that we can tap into and use pre-existing functionality. So let's take a look here at our SVF. Here is The first one I'm going to show you here is our format currency. Remember, we did this in a previous video here with our user-defined functions. We built a function that would format currency in SQL. Now, this would actually function a lot better, and it's a little less code too, in Visual Studio.net and specifically here VisualBasic.net, because it comes with the string.format function. And inside of here, we're just using quotes. We're saying the first parameter here, because you can have multiple, what do they call, arguments? You can just keep going, argument, argument, argument. And then it's kind of broken out where 0 argument, because it's 0 based, and C stands for currency, formatted as currency. So that's all we're doing. String.format, the first argument, of course, we only have one argument in here, and this takes one parameter, a number. So we're going to pass a number in. It's going to get formatted as currency and passed back as a SQL string, a SQL type.SQL string. And that's where this Microsoft.SQL Server.Server library comes into play, is all these SQL types are stored in there because you have to return them back to SQL Server as a type that SQL Server can understand. So you can see a very, very simple function here. And another thing here, these are called attributes. And attributes, really, they just define, if other developers were to use this, they would get friendly tooltips if they were to use this function, just in metadata. Really, it's just metadata about this function, data about the function. So this is just a generic scalar UDF, formats the numeric value coming in as currency, and returns it as a string. Now, this scalar UDF does not actually perform any data access, so I put the tag up here in the attribute that says data access equals none. And again, this is just helpful for developers to see that this function would not perform any data access. Now, below we do have a data access scalar UDF, which returns a product stock. Given a product ID, we actually have a stored procedure that we built that does this exact same thing. And how this one works is, same thing, we have the name of the function here. It's a product ID coming in as a parameter. It's going to return back to SQL Server an integer. And you can see we don't actually have a SQL type on this one. It's because the integers are pretty much compatible. They can be converted on the fly. SQL Server understands that an integer coming from Visual Studio, or the CLR, is an integer that I can understand over there in the SQL Server world. So that's kind of nice. And basically how this works is, you can see we're using a SQL connection. We're saying using con here, a brand new using statement in Visual Studio 2005, which basically what instantiates here, creates this object, gets us a SQL connection. And this is kind of cool here. This is something that we can only do within a SQL Server UDF. We say context connection equals true, which means it's going to use the connection of the individual that is running the stored procedure. So that makes it pretty easy. You don't have to really worry about security because it's already handled by SQL Server. We open the connection. We create what's called the SQL command, which just takes a SQL statement, and then all we're doing from here is we're just basically grabbing the quantity, basically the supply for this product ID from the product inventory table using the parameter that's getting passed in and the connection we created above. So the last line of code here is the return statement, and again, just like a user-defined function in SQL Server, return signifies to the function that it's done processing, it's ready to return a result. And basically what we do here is we do this command.execute scalar, and this is the command that's going to actually execute this transact SQL code, return that value, and then we're just converting it to an integer here just because that's what the function is expecting, and that'll all get returned back to SQL Server. So there's a couple of scalar valued functions that we'll take a look at. We'll learn how to, again, create wrapper functions that use these within SQL Server when we get there. But let's head down here and take a look at a cool table valued function that I threw together. And this one is kind of special because this is actually a streaming table valued user defined function, and that the user won't have to wait for the entire result set to get generated before it sees it, before the user sees it. Because how streaming table valued functions work is as soon as a row is found, a record is found, it immediately gets passed back to the user. So the user is seeing the results as they happen, rather than, again, for these results to get fully materialized before they get passed back to the user. So really cool stuff here. Now, what is really cool about this is this entire table valued function that I'm about to show you here actually doesn't have anything to do with SQL. What it does is it's a directory search. It'll search your hard drive given a root directory, a search pattern such as star.xml if you want to find all the XML files on your computer, and then a subdirs as a boolean here if you want to traverse and find all of these files in subdirectories. So a very, very neat table valued function that you can use in SQL to search your hard drive, and it'll turn back in tabular format all of your files. And we could do this in previous versions of SQL using the XP command shell, but I tell you, it wouldn't have been very easy to do, nor is it very safe or secure to do, more importantly. So let me just run through this and kind of give you an idea how this works. If you're a non-programmer, hang in there. It's actually not too bad because there's not a lot of code. But basically the magic of a streaming table valued function sits right here with this fill row attribute. Basically what we need to do here is we have an entry point function. When we create a wrapper table valued function in SQL Server around this, this is all SQL Server is going to see, is this one directory search function. These are all private here, and you can see this function actually uses these three to do all of the work. So how this works again is this: we signify to this entry point function directory search here that it has a fill row method name called fill row. And this is where all the magic in the streaming comes back, because again, when the user executes this function, it's going to get returned to them one row at a time. So this is, again, pretty neat stuff. But basically, here's the fill row function at the bottom. The CLR, once it finds a row, it'll just basically grab all these data metrics and pass them back to the user, as was signified here as out params. This is what does all the magic too, is these out parameters. They have out tags before them to notify that they're going out. They're getting returned back to SQL Server. Now back to the top. Let me just try to run through this quickly. The directory search function, our entry point function, just simply creates an array list here, which is just a list of objects in an array. And then we call this do directory search, which is kind of the, again, another function that is going to use the gut of the function here, the guts of the function, to actually do the directory search itself. This just does a directory search. It calls the get directory files, okay? Get directory files is going to accept pretty much the same parameters here, just the directory, the pattern, and the data. And it's just going to do that on the root directory first. Then if there's any subdirectories, in other words, if we have the subdirectory flipped on here, meaning go ahead and search subdirectories, then it's going to search all the subdirectories in the root directory and just keep doing. This is kind of a recursive search here because it calls itself. And it's just going to keep going through all the subdirectories in the root directory, and both of these call this get directory files here. This is really where the bulk of the work is. It just takes a directory, a pattern, and the data that it's going to get returned back. And it just loops through using the for each. Again, here's the for each construct. For each file in the directory.getFiles, basically it's just going to go find all the files. It's going to instantiate a file info object, passing in that file, and then get the name of the file, the creation time, the last time it was written to, and the last time it was accessed. Throw that in an object, throw that in the array list, and return it back. So it's going to do this basically for every file in the root directory, and then if subdirectories are turned on, for every file in each subdirectory. And that's the bulk of the code. And again, the fill row function, then every time that it finds a file, it's going to call this fill row function, which is going to get those data metrics out of this object, pass it back through these out parameters back to SQL Server, and SQL Server, the user, will see these results one row at a time. So again, it looks complex, but it's really not. There's not a lot of code here. So I'm actually going to include this project here so you can take a look and try to dissect it yourself and see how it works. But the point is here, we have a couple of scalar valued functions in one table valued function that's actually a streaming table valued function that we can now use within SQL Server. Now the final steps, once we have again our code set up, or we have two scalar valued functions, one table valued functions, we want to use these in SQL Server. How do we do it? Well, the first thing you need to do is compile this into a DLL. We compile this by right-clicking on the project and choosing Build. Right? That'll build it into your output directory, and our output directory in this case is going to be a really long directory name. But basically here, let me go ahead and run through my documents, Visual Studio, projects, SQL library, bin, debug, and there it is. There's our DLL. This is what we're going to be using here. That's all of the code inside of there. So let's head on over to SQL Server Management Studio. First thing we're going to do is configure our server for CLR integration. And to do that here, you just run the spconfigure system store procedure, pass in the string CLR space enabled, comma 1. And this will actually configure the server and allow CLR objects to be executed within the server. And then you run a reconfigure, so it'll automatically reconfigure and allow it on the spot rather than waiting for a SQL Server reboot. So let's go ahead and highlight this code and hit execute. And there it is, configuration option CLR changed from 0 to 1. And then of course it says run the reconfigure statement to install, which we already did. So now we're ready for CLR integration. So the next step is to get our assembly in here, get our DLL into our database so we can actually use it. There's a couple of ways to do it. You can do it in code here using the create assembly statement. I'll show you the interface way to do it here first, and then when we update our assembly, which we'll do when we recompile it because we have stored procedures to do, I'll show you how to do that in code. So what we do here is we come into our database, we go down to programmability, down to assemblies, and you can see there's no assemblies in here right now. To get one in here, we just simply right click on it, choose new assembly, and this is going to go ahead and open up the new assembly dialog. First thing we need to do here is just set your permission set. We have three choices. We have safe, external access, and unsafe. Safe is for when you're only accessing things within SQL Server, such as those first two functions we built would have been fine at the safe level because we're using everything. We're just simply formatting currency in this one. In this one, we're just doing a get product stock, but nothing is going outside of SQL Server, so safe would have been fine. But since we're accessing the hard drive here in our table valued, streaming table valued function, safe wouldn't be good enough because SQL Server wouldn't allow us to actually execute that function. External access is what we would need. External access simply means that you're going to access resources outside of SQL Server. We also have unsafe. Unsafe means you're going to access any sort of operating system resources. Maybe you're tapping into the Windows API within your code library. That's where you would need unsafe. So we're going to choose external access here just because we are, again, accessing the hard drive there within our streaming table value function. The next thing we need to do is just simply browse to the DLL. So I'll hit the browse button. We'll browse right to that DLL that we were in here. Bin, debug. There it is. Hit open. That's all there is to it. Now we hit OK. It's going to go ahead and do what it has to do, and we should have, within SQL Server, our SQL library imported, but we're not. And you know why? Because we have one problem here. If you're going to do external access, and you can see here, let me just show you, if we did safe and hit OK, look at this. Boom. Now it's in here. You actually cannot turn on external access without doing one special little thing here, and that special little thing is turning on a database option. So we need to do alter database, and then the name of the database, AdventureWorks, set trustworthy, there's a trustworthy property here, on. And what this will do is basically we're trusting this assembly within our database. We're trusting it for unsafe or external access. So we need to turn this on. Another way to do this is to strong sign your assemblies. And if you're not sure what that is, it's not hard to do. You just basically create what's called the strong name key and associate it with your assembly in Visual Studio, and then you wouldn't have to turn this property on. But this is another way to do it. So if we hit execute there we go. Now if we head into the properties of our assembly and switch this to external access, we shouldn't have a problem here. If we hit OK, boom. Now we can access externally anything within our user-defined functions. And you can see here the other way to do that, again, using the create assembly statement followed by the name that you want to import it as. And then from is just a long path here to the actual assembly. And then you can use with permission set equals safe. You actually don't need this. The default is safe. But if you want to do anything other than safe, then you'll have to type it in here. Again, external access or unsafe. Now, the next thing we need to do is create our function in SQL Server. So we do the same thing. Create function followed by the name of the function followed by any parameters that it's going to be expecting. We then put the return on here, return in this case an end varchar 100 as, and here it is, external name, and this is just going to reference using kind of the naming convention following through the namespace of the actual library itself in Visual Studio here, which I'll show you how this works. We just reference that method. So remember the name of our method over in Visual Studio is format currency. Here it is, right? And so it goes SQL library dot svfs dot format currency because svfs is the name of the class here. Now this is the way it's supposed to work. We're supposed to be able to do just that. SQL library dot svfs dot format currency. Apparently though there's a small bug in SQL Server 2005 that will hopefully be fixed, and you have to do this little workaround where you have to go SQL library dot, and then in brackets here you have to do it again, SQL library dot name of the class, and then close the bracket, and then dot name of the method. So you are supposed to do it, just be able to do SQL library. So basically the name of the library, name of the DLL, or name of the assembly that you imported as, name of the class, name of the method. That's how it's supposed to work, but obviously it doesn't. So you have to kind of do this little workaround here. But it does work this way. All we have to do then, highlight our function, hit execute, boom. Now, if we head over to our functions, scalar valued functions, let's go ahead and refresh this. There it is, our CLR format currency. And you can't even tell that this is a CLR function, really. I mean, the properties don't give it away. Nothing really gives it away that is a scalar valued function, or excuse me, a CLR function. The only thing is I name them that way so you can see them. That's a good way to differentiate them. Other than that, they pretty much work the same, except performance, of course, on format currency will be a lot better on this one as opposed to this one. Remember, we made our own user-defined function called format currency, so performance will be better on the CLR version. Also here, our get product stock. This is the one that does the data access, so we'll highlight this and hit execute as well. There we go. Now we should have this scalar valued function as well. We have both of them. Now let's go ahead and use our scalar valued functions. The first one, our format currency, and you can see here we have them set up. Same query we used back in our user-defined function video, except we're using the CLR version. Let's highlight it all, hit execute, and there it is. Went out and formatted all of that data in all four of these columns here as money. So pretty cool stuff there, very simple to use. Same thing here with our get product scout. Here's our data access scalar CLR function. We highlight this code, hit execute. It's going to bring back, and you can see the data access is a little bit slower here as it would have been using a built-in user-defined function, because again the CLR isn't, it was built for complex calculations and logic where TransAct SQL is best at returning data. So you may want to, this would probably be a good candidate to keep as a user-defined function within the database rather than writing it in the CLR. Where this one, the format currency, perfect for the CLR. Now let's move on down here to our streaming table valued function. And again, if you're going to do anything such as we're doing here where we're accessing resources outside of SQL Server, you want to make sure that your permission set on your assembly is set to external access. Again, the functions we wrote up here, these would have been fine for safe access because they're staying within SQL Server's boundaries. This one, however, again, it's searching a hard drive. It's searching files within the operating system, so it's outside of SQL Server, and therefore we need external access. Now, again here, very, very simple to create this wrapper function. We just need to give it a name. Pretty much the same exact thing as the other functions. The parameters here have to match the parameters within our assemblies here, within our .NET environment. As they do, you can see our parameters on the function, root directory here, search pattern, subdirectories, and if we look over here, we have the same ones, root directory, search pattern, and subdirectories, all the same data types as well. Also, since this is a table valued function here, we need to set up the returns table statement, and then these have to match your out parameters on the fill row method. If it's a streaming table valued function. If it's not a streaming table valued function, then whatever method you're creating, they still have to match the out parameters. So we have file name, created, last updated, and last accessed. And again, over in our assembly here, down in the bottom in our fill row statement, same thing as our out parameters, file name, created, last updated, and last accessed. So we're okay. We're all set up. We're all matched here. The only other thing we need to do then is just reference the actual method within our assembly. So you can see here we just, again, external name of the class library, or the name of the DLL, or whatever you imported the assembly as. And then again, in brackets here, name of the class, name of the class library, name of the class, and then name of the method that we're referencing. Let's go ahead and highlight all this, hit execute. Now, in our table valued functions, if we refresh it, check it out. We have our CLR directory list, which is our directory surfer here. There we are. Now we just need to use it. So let's go ahead here and highlight our code, select star from dbo.clr directory list. You can see our parameters here are C:\Windows. Our root directory here is going to be Windows, the Windows directory on the C drive. We're going to search for all XML files here, star.xml. So every XML file within the Windows directory, we're going to pass in a 1 as a third parameter, which means go ahead and search the subdirectories as well, so we can grab every single XML file within the Windows directory of our C drive. Now, note that this is going to run on the actual SQL server here, because that's what we're connected to. So, and of course, that's where the function lies. So it's actually going to search the C drive over on our SQL Nugget machine. So that's kind of cool as well. Good to know. And it's pretty cool here that we can actually do a select star from all this, and we can put where clauses on. So again, just very, very powerful stuff here that we can return as a tabular format within SQL results from the hard drive. And again, I'm going to hit execute here. Now, because we're introducing another layer, which is the operating system, and searching files on it, it may not really be apparent that we have a streaming table valued function that's going to return this row by row, and you couldn't really see it there. The reason being is because this isn't directly in SQL, so it's not going to be able to grab these, grab the records immediately and pull them back one by one and display them to us one by one. And plus, we're going through the network through another server as well there. But it did return those pretty fast. That's actually really fast to search the entire Windows directory over there and then return it back over here. 257 files to be exact, and look at that, we get them all. All the XML files over there in the Windows directory on our SQL Nugget machine. So pretty cool stuff. And that is, again, a streaming table valued function. That's how we do it. And let's go ahead and move on here to stored procedures. So let's head on over to visualstudio.net here and take a look at the stored procedures class that I threw together. And again, here we want to import the same libraries because, again, we're going to be working with, these are going to be SQL Server tagged methods and sub-procedures in here. And here's the stored procedures class that I threw together. you have a couple of simple subroutines to work with. Again, all these subroutines are going to be marked with this attribute to note that they're stored procedures. This will tell the actual assembly that these are stored procedures, and this is how SQL Server will also know that they're stored procedures. So, and here's how this works. Here's a very, very simple, just a simple sub here, return message. We do a SQL context, and this SQL context is really cool. This just basically means it's going to use the context, connection, security, everything relating to the individual that's running the stored procedure. So we do a SQL context.pipe, and this is, of course, a named pipe. That's how SQL, whenever we run queries, it returns the results through us, messages and results, through named pipes. So that's all we're doing is we have direct access to this pipe here. So we're doing a SQL context.pipe.send, and when you send a string over, it's going to send it as a message, right? So the messages, if you remember, if we head on over here for a second, I'll just pop open the results of our previous query. These are results, these are messages. So we have control over both of them within Visual Studio here. And just to show you, if you do a send and you just send a string over, there's three different instances that we can send here. We can send a message as a string. We can send a data reader, which is of course going to be just a tabular result set. And we can send an actual record itself, just a regular old SQL data record, which is basically just one row. And we can dynamically build that row as well. So those are your three different versions of the send here. And this one is just very simple. If we were to wrap a stored procedure around this, which we will, and we call it, there you go. We'll just get a hello from the CLR within the messages tab in SQL Server. Also here, if we want to pipe result sets, actual queries here, there's another thing we can do. And here's what I'm doing here. I'm using, again, the new using statement to instantiate a connection object, a SQL connection object. Again, we're using the context connection equals true here. Same thing. This just basically means we're going to take the security context of the individual running the stored procedure and use that. We open the connection. We create a SQL command. And this is just going to use a global variable here within SQL Server to grab the number of connections. And then SQL context.pipe.execute and send. Again, execute and send here is going to do both. It's going to execute the command and send the results back to the client. And there we go. There's our, this execute and send actually takes a SQL command. So it does two things at once there. It executes it and sends those results right back to the client as a result set. So this one will return a message. This will return results. And down here, I have another one. This is actually going to do just a simple output parameter. It's going to return an output parameter based on a query that we're going to supply to it. And really the point I wanted to make about this one specifically here is that we're doing calculations. We're doing both here. We're running a query, we're getting the data back, and then we're going to do calculations, compile it all. We're basically doing our own sum function here to compile all this data and then return it back formatted. You can see this is kind of cool that we're using the format currency here over in our UDF area. We're actually going to tap right into this function to format the results and send it back. So that's again a nice thing about the library here is we can use functions within within our own library. We're not restricted. We're not just creating these for other user-defined functions in SQL Server. We can use them ourselves, right? So this is pretty cool stuff here. And just to show you what I'm doing here, again, pretty much the same thing. Just grabbing a connection, opening it, creating a command. This command is going to run a query that just grabs all of the subtotals from this. So every single sale that we've ever had in the AdventureWorks company, all the subtotal rows. So this will turn us back a ton of rows with all the subtotals from every single sale. This time we're going to create a data reader here. We're going to execute the reader, which will get those results and store them into what's called the SQL data reader, which is just basically a table for all intents and purposes. And then we're going to create a decimal value here, and then we're just going to loop through every single row within this data reader and compile it into this decimal value. You can see that's what the plus equals does here within the loop, and it's just going to convert it to SQL money on the way. So basically we're just going to get a big number, which is all of these subtotals compiled into one. So it's a sum of all the subtotals. And at the very end here, we're returning as an output parameter. As you can see here, this is where the out, again, is specified. This ret value as a SQL string. We're converting this value into a string because we're passing it to this format currency function, which will take the number format as currency, return it as a SQL string, which will then return it as an output parameter back to the results within SQL Server. So we'll take a look at how to wrap this and use this here in SQL Server as well. So the final one that I want to show you here does both. It sends messages, executes a command and returns results, and then sends more messages. So this is really more like we were showing you over here where we get both results and messages. This does it both, results and messages. And what this here does is it just gets products. This will just get a product listing. We're selecting the name, the product number, the list price from our product table there. And the cool thing is we're using this send in more than one fashion here. You can see the first send, we're sending a message. Execution began, and then now.toString will get the current date and time. And then we're going to execute all this code, which again opens a connection, runs a query, gets that data reader back. We do an execute reader to actually execute the command and get the data reader back. And then we use the send function a little differently here because, again, we're sending a data reader. So since we're sending a reader, SQL is going to know that these are results here. And then at the very end, we're just sending back another message saying this is all done, and we'll get execution ended. So the result then will be two messages, began and ended, and then the results of all the products within the AdventureWorks database. So you can see, not a lot of code here. Very easy to do this type of stuff. It's really just, again, getting a hang of the syntax and how this stuff works. But really the key to all of this, the magic here, is the SQL context object. And then if we send results back by using the pipe.send. Very cool stuff. Now, before we head back over to SQL Server, what we need to do is, remember, our developers are going to be updating these assemblies constantly. So we need to, of course, refresh the assembly within SQL Server. So what I'm going to do here is let's say that we updated this class with these stored procedures. What do? Well, the first thing we need to do as developers, of course, we'll come in here, we'll update the version number by showing all files. We'll go into my project here, into the assembly info file, and at the bottom, we're just going to update this the assembly information here to version 1.0.0. All right, so now our assembly is updated, and we'll see that reflected in SQL Server as well. The next thing we do, we'll unshow all files here. We'll right-click on our project and choose Build. So this will build the updated version. Now we have 1.1.0 of our assembly. Now what we need to do is head back over to SQL Server, and to refresh these assemblies is pretty simple. But the thing to know here is you can't, if you have functions out here and such that are already relying on this DLL, you can't just delete this and re-import it, which is the only way to do it. Unfortunately, refresh and stuff doesn't do it. It actually doesn't refresh the assembly here, and there's no way to do it graphically. You have to run the alter assembly statement. So if you have functions out there that rely on this, you won't be able to delete that. You'll have to run this alter assembly statement. And since we did that initially, we actually imported it by browsing this hard drive. But since this assembly is over there on the other server now, SQL Server is managing it, we need to actually doing this and referencing this file here on our local server. It's going to say, I can't find it. Sorry, where is the file? So what we have to do here is just take this file, our assembly over here. I'm just going to copy it. And then we're going to head on over to our SQL Nugget machine. We'll just head into the C directory here, going through the administrative share. And I'll paste it in there into the C drive. Now, if we just change this to say C:\/ in the name of our assembly, now we should be able to do it. So this should work. If we alter assembly here, SQL library, pointing to that DL over there on the SQL Nugget machine, and voila, there we go. So now our assembly is updated. Now let's go ahead and refresh this and view the assembly. We should have 1.1.0.0. There it is. So now our assembly is refreshed, and that's how you refresh assemblies. Best way to do it. All right, let's get back to stored procedures here. Now, how we create these wrappers around our CLR stored procedures is the same as we do with user-defined functions. We do a create procedure here, followed by the name of the procedure, any parameters that we may have on our stored procedure, our CLR stored procedure. We do an as, and then same thing, external name followed by the path to get to our function that we're using within our assembly. So we highlight this code, we hit execute, boom, it executes. Remember, this was our message one, so this will return our message. And to execute it, just like executing the standard stored procedure as we do any other stored procedure here, just by its name, we hit execute and check it out. Hello from the CLR, and if we scroll back over here into our stored procedures, that's exactly what we did here. Hello from the CLR. So again, that's our message. So that was our message stored procedure. Here's our result stored procedure. Same thing. Let's execute it to create it, and execute the actual stored procedure itself. We'll return the results. Remember, this time we were returning the number of connections since the last time SQL Server was started. You see, I got quite a bit of connections in here since the last time SQL Server was started. It's been a long time since I've rebooted 296,000 connections. And that's that. So, and here's our get sales total. Well, this one actually returned our output parameter. So we do a create procedure, name of the procedure. We declare our parameter here, total sales, as an n varchar, maxed out, with an output tag on here to note that's an output parameter. And then we just, again, reference that method over there in our assembly. So let's create it. And then we use it just like any other stored procedure that it takes output parameters. We declare a parameter here. we execute our stored procedure, declaring, again, passing in that parameter, declaring it as an output parameter, and then we're just going to print those total sales here to the screen, and we'll hit execute. And this is going to go compile all that data and print the total sales for the lifetime of all the products here within the AdventureWorks company. And that's what we get. And you can see it all comes nice and pretty formatted here because we did that ourselves here using our format currency function over there in the UDF class. So pretty cool stuff there too, huh? Now, the last one we had was our get products. Again, this one did both. It returned a message and it returned results. Remember those execution times I was showing you? So let's go ahead, highlight this code. That'll actually, again, create our CLR get product stored procedures, and let's execute it. There it is. Here is a product listing, all the products in the AdventureWorks database, and look at that. There is our execution began, data returned, execution ended. You see pretty fast there to execute that, but that's all there is to it. And again, these stored procedures look the exact same here. The difference here is that they automatically have this lock sign on it because you can't see, you can't really see the definition because the definition is stored within the assembly. So that's another big difference that you will be able to tell graphically here within, although you may think they're encrypted, and just name them appropriately and you'll know that they're CLR stored procedures. Alright, so in the CBT Nugget we took a look here at working with managed code. We started off getting familiar with what managed code is, what the CLR is, and how it integrates with SQL Server 2005. And really, we just saw that the CLR, the Common Language Runtime, is just the heart of the .NET framework. And I started off there just kind of giving you a bird's eye view of how the process works, and also what type of objects we can create in the CLR, such as stored procedures, user-defined functions, user-defined types, triggers, so on and so forth. Also the benefits, the advantages of using CLR objects versus their SQL Server counterparts, and certain situations for both of them. And really it's going to come down to performance and also usability, manageability. Doing something in the CLR may be 100 times easier than doing it within Transact SQL. We then took a look at how to create these objects. I just kind of briefly ran you through how to create both types of UDFs, scalar valued UDFs, table valued UDFs. Specifically there we took a look at the more advanced table valued UDFs, the streaming table valued UDF, which is a very, very cool feature within the CLR and SQL Server 2005. We then took a look at how to use those UDFs by enabling CLR integration, registering our assemblies, creating those wrapper functions around the CLR functions so we can use them just like we use regular old functions within SQL Server. The only difference is they're, of course, CLR functions. They're just wrapper functions around the CLR functions within the .NET framework. And at the end here, we took a look at stored procedures, how to build stored procedures within Visual Studio.NET and creating assemblies out of them. Again, registering those stored procedures, updating our assemblies, and then creating those wrapper stored procedures around our CLRs and using them. I hope this has been informative for you, and I thank you for viewing.